National Electrical Code Section 700.12b addresses the separation of emergency systems from normal power systems. This section is very specific about maintaining the independence of the emergency power supply to ensure its reliability during power outages or other emergency situations. The core principle of Section 700.12b is electrical isolation. The emergency system must be electrically isolated from the normal power system. This means that the two systems cannot share any common components, wiring, or raceways, with a few exceptions outlined in the code itself. The purpose of this isolation is to prevent a failure in the normal power system from affecting the operation of the emergency system. If the two systems were interconnected, a fault in the normal system, such as a short circuit or ground fault, could propagate to the emergency system, causing it to fail as well. This would defeat the purpose of having an emergency system in the first place, which is to provide a reliable source of power for critical loads when the normal power supply is unavailable. Section 700.12b has specific requirements concerning wiring. The wiring for the emergency system must be kept physically separate from the wiring for the normal system. This can be achieved by using separate raceways, conduits, or cable trays for the two systems. In some cases, it may be permissible to run the emergency wiring in the same raceway as the normal wiring, but only if certain conditions are met. For example, the emergency wiring must be clearly identified, and it must be protected from physical damage. Section 700.12b also addresses the issue of transfer switches. A transfer switch is a device that automatically switches the load from the normal power source to the emergency power source when the normal power fails. The transfer switch must be designed and installed in such a way that it provides a reliable means of transferring the load to the emergency source. It must also be electrically isolated from the normal power system to prevent a fault in the normal system from affecting the operation of the emergency system. One common question that arises with Section 700.12b is whether it is permissible to combine normal and emergency power in the last junction box before an exit sign or emergency light. The answer is generally no. The code requires that the emergency system be electrically isolated from the normal system, and this means that the two systems cannot share any common components, including junction boxes. There must be a separate junction box for the normal power system and a separate junction box for the emergency power system, and then separate conductors must be run from each junction box to the exit sign or emergency light. There are a few exceptions to this rule, but they are very limited. For example, it may be permissible to combine the normal and emergency power in the last junction box if the junction box is specifically designed for this purpose and if it is approved by the authority having jurisdiction. However, this is not a common practice, and it is generally best to avoid it if possible. Another important consideration with Section 700.12b is the voltage levels of the normal and emergency power systems. If the two systems operate at different voltage levels, it is especially important to maintain electrical isolation between them. For example, if the normal power system operates at 480 volts and the emergency power system operates at 277 volts, there must be a clear separation between the two systems to prevent a high voltage fault from affecting the low voltage system. This can be achieved by using separate transformers for the two systems and by ensuring that the wiring for the two systems is properly insulated and grounded. The requirement for electrical isolation between normal and emergency power systems is a critical safety measure that is designed to protect building occupants in the event of a power outage or other emergency situation. By maintaining the independence of the emergency power supply, it is possible to ensure that critical loads such as exit signs, emergency lighting, and fire alarm systems will continue to operate even when the normal power supply is unavailable. It is important for electrical contractors and installers to be familiar with the requirements of Section 700.12b and to follow them carefully to ensure that emergency power systems are installed in a safe and reliable manner. Compliance with Section 700.12b is not only a matter of safety, but it is also a legal requirement. Failure to comply with the code can result in fines, penalties, and even criminal charges. Therefore, It is essential for all electrical professionals to take this requirement seriously and to ensure that they are properly trained and equipped to install emergency power systems in accordance with the code. Firstly, consider the specific wording of NEC Section 700.12b and any applicable local amendments or interpretations. Authorities having jurisdiction, OJs, may have specific requirements or interpretations that you must follow. Secondly, ensure proper separation of wiring. Run normal and emergency power circuits in separate conduits or cable trays. If they must share a raceway for a short distance, use a physical barrier or divider within the raceway to maintain separation. Thirdly, use separate junction boxes. Install dedicated junction boxes for normal and emergency power circuits, especially for the final connection to exit signs and emergency lights. Fourthly, maintain clear identification. Clearly label all emergency power circuits, conduits, and junction boxes with appropriate markings such as emergency power or emergency lighting. Fifthly, verify proper grounding. Ensure that both the normal and emergency power systems are properly grounded in accordance with NEC requirements. Sixthly, test and document. After installation, thoroughly test the emergency power system to verify its functionality and document the testing procedures and results. Seventhly, consult with an electrical engineer. For complex installations or if you have any doubts about the code requirements, consult with a qualified electrical engineer for guidance. Eighthly, consider the voltage levels. If the normal and emergency power systems operate at different voltage levels, take extra precautions to maintain separation and prevent accidental contact between the two systems. Ninthly, use listed equipment. Use only listed and labeled equipment for emergency power systems, including transfer switches, generators, and lighting fixtures. Tenthly, stay updated on code changes. The NEC is updated every 3 years, so stay informed about any changes or revisions that may affect emergency power system installations. Failure to adhere to these guidelines can compromise the integrity and reliability of the emergency power system, potentially endangering lives in the event of a power outage or other emergency. Therefore, it is crucial to follow the code requirements and best practices to ensure the safety and functionality of emergency lighting and power systems. Additional considerations for emergency power systems are as follows. Firstly, load calculations. Perform accurate load calculations to determine the appropriate size of the emergency power source, such as a generator or battery system. Secondly, transfer switch selection. Choose a transfer switch that is properly rated for the connected load and that meets the requirements of NEC Section 700. Thirdly, generator sizing. When using a generator as the emergency power source, ensure that it is sized to handle the inrush current of all connected loads, especially motor loads. Fourthly, battery backup systems. For battery backup systems, select batteries that are specifically designed for emergency power applications and that have a sufficient capacity to power the connected loads for the required duration. Fifthly, maintenance and testing. Establish a regular maintenance and testing program for the emergency power system to ensure that it is always in good working order. Sixthly, coordination with fire alarm systems. Coordinate the emergency power system with the fire alarm system to ensure that the fire alarm system will continue to operate during a power outage. Seventhly, signage and labeling. Provide clear and conspicuous signage to indicate the location of emergency power equipment, such as generators, transfer switches, and battery rooms. Eighthly, training. Provide training to building personnel on the operation and maintenance of the emergency power system. Ninthly, documentation. Maintain detailed documentation of the emergency power system, including wiring diagrams, equipment specifications, and testing records. Tenthly, compliance with local codes. Ensure that the emergency power system complies with all applicable local codes and regulations. In addition to the requirements of NEC Section 700.12b, there are other NEC articles that are relevant to emergency power systems. Some of these include NEC Section 700 Emergency Systems, NEC Section 701 Legally Required Standby Systems, NEC Section 702 Optional Standby Systems, NEC Section 705 Interconnected Electric Power Production Sources. It is important to be familiar with all of these articles to ensure that emergency power systems are installed in accordance with the code. Also, remember that it is critical to prioritize safety and compliance in all electrical installations, especially those involving emergency power systems.